This question has got everything I could hope to show you and teach you. So there's a lot that we're going to cover in this video. I'm just going to, as I read information, fill in. That's a good habit to do. So I tell my students, don't read everything and then try and look to answer a question. As you read a sentence, just pause and fill in what you can. So let's do that together, and then we'll hit the two questions, and I'll give you a couple of tips along the way. For starters, they say FG is tangent to the circle with center E. Okay, so just the fact that E is the center, I'm going to fill in all the radii immediately. And FG is tangent to the center, so that makes an angle of 90 degrees there. Tan perpendicular to radius. Because something from the center, so F is the center of this semicircle, is perpendicular, therefore it means that it bisects this line in two. Then other information, it says that CD and CE are tangents, so these two are tangents, so tangents meet at a point, and so these two lines are also equal to each other. And they tell us and show us that CD is parallel to HE. So if I'm approaching a question like this, what I would probably do is, I've got these two lines equal here. So there's an isosceles triangle. So it's helpful to let something be x to just get the question moving along. That would make this angle 180 minus 2x, sum of triangle. Because there's parallel lines, alternate angles will make this 180 minus 2x, alternate to this angle. And then this is a isosceles triangle because of the rule of the tangents meeting at a point. So if this is 180 minus 2x, then these two guys in the corner must have both been x. So it's helpful just to fill in everything we can before we begin. I know this will be a little bit busy here in the corner, but I like to just put all the lines that are equal. So there was a DG equaling a GE, which equaled an HE, which equaled KE. Those are all one stripe in my picture. There was also a CD equaling a CE. And so it helps just to leave those to marinate on the side throughout the question so I can use it whenever I need. Proving these two triangles CDE, this big triangle that for us at the moment we've worked out has an XX and a 180 minus 2x, and HEK, which is a XX 180 minus 2x. So we've, through all the reasoning I've talked through, we've proved that those two are similar because they've got three angles the same. And so immediately, before I even think what the next question down here is, I'm just going to write the ratio of fractions. First two over the first two should be the same as the second two over the second two. Should be the same as the first and last over the first and last. How do I know all of that? It's because the triangles are similar, and so I would get into the habit of doing that immediately. Then when you see something like this, if it didn't have the 2 in front, it would potentially be quite a normal rearranging these letters into fractions and looking across and down to see which triangles I'm trying to prove similar. The fact that there's a 2 makes it a bit of a headache, and so we'll come to that headache just now. For starters, what I like to do when I'm trying to prove something complicated is just look, where do I see those letters in what I've already proven? So there's the DC, the HK is down here, there's a HE here, and I'm missing another 2 HEs, and I'm missing a DE. And so it seems pretty clear from what's going on that we're going to be using these two fractions. So let's dive into the question with that and just see where it goes. So I want to end up with a HE on the top, so I'm going to times this up there. So it will be HE times DE, and I wanted the DC and HK, so there it is. I just times it up, and that's done. Then a helpful technique here is, if you can see flip, I'm almost there, except I need to get rid of this, and I ideally need it to be 2HE. I need to get rid of this, and ideally it needs to be 2HE. So you're almost thinking backwards and forwards constantly rather than just going in autopilot. Then if I can get that, I know that I'm going to get the answer and get full marks. So then it helps just look in the picture, look up here to see what we've got. So does DE, which is this entire line, which is made up of 2 of these lengths, is that equal to HE? And because I can see that HE is the same as the DG and the GE, which were both one line, then this is true. So just by looking at the picture, DE, this entire line, is 2 of these single lines. So I can just replace that there. And when I do that and times it out, it gives me exactly what I need and want. And so this is hopefully a really helpful video just for filling in as much as you can as you read a question. If you notice any lines are equal, pop them at the top in case you need them. Seeing a complicated question and just looking what you have, like I highlighted, to know where to then begin with. And when you feel stuck and you can't get the answer that you're desiring, just pause with what's the extra unwanted information. Think what you would ideally want it to be and see if you can see the connection in the picture. I hope this video was helpful. If it was, please like it, subscribe to our channel, and share it with your friends.